So the next two sections are probably the longest sections of the course. So let's go through them. First is verifying properties of geometric figures. So here we have at the top a summary of some of the formulas that we know. We have the slope formula, the length of a line formula, the midpoint formula, point-slope form of an equation, and y-intercept form of an equation. So here, let's see what it said. It says, for any 3 points A, B, and C not in a line, M and N are the midpoints of A, B, and AC respectively. How can you prove that these are parallel? So let me just draw this. So we have 3 points, A, B, and C, and they're clearly not in a line. M is the midpoint of AB. M is the midpoint of AB, and N is the midpoint of AC. Okay, how can you prove that MN is parallel to BC and that MN's length is half the length of BC? So, what you would do to prove that MN is parallel to BC is you would take the coordinates of M and N and find the slope. You would take the coordinates of B and C and find the slope, and then you would see if they're the same. To find if the length of MN is equal to half the length of BC, you would do the length formula for MN, you would do the length formula for BC, and you would see what you end up with. Is this half of this? And then you'd know. Okay, next is a triangle DEF has vertices, DEF as stated. Classify the triangle as right-angled or not. So what do we need to do? Okay, so if you didn't just say it in your head, say it in your head so you know what you're going to do. And now I'm going to say it, and let's see if it's the same thing. You're going to find the slope of DE, the slope of DF, and the slope of EF, and see if any of them are negative reciprocals of each other. Awesome. So you know how to do that. Let's go on to the next one. The vertices of a quadrilateral are STU-V. Verify each of the following. Verify that STU and V is a parallelogram. So, of course, when you plot STU and V, sorry about that, guys, there we go. When you plot STU and V, let me fix this one a second. You're going to see what looks like how it would attach. Does S attach to U, which attaches to V, which UV, or does S go to, you'll look and see, and then you're going to see if opposite sides are parallel. You know how to find the slopes of parallel lines. You know how to find the slope of a line. You're going to see if the diagonals bisect each other. So what you'll do is you'll find out if they have the same midpoint, right? Like here, for example, if this line cuts this line in half and this line cuts this line in half, then wouldn't they have the same midpoint? This line cut in half here, this line cut in half here. So you're going to find the midpoint of one diagonal, find the midpoint of the other diagonal, and see if they're the same. If you want to know if STUV is a rhombus, well, you've already seen that the opposite sides are parallel. So what you'll do is you will take a look and see if all the sides are equal in length, rhombus. And then, if you want to know if the diagonals of these are perpendicular to each other, you're going to have to find the slopes of the two diagonals and see if their slopes are negative reciprocals. So that's how you do that. Next, Here's another question. ABC, triangle ABC has vertices, blah, blah, blah. Find the equations of the three altitudes. Okay, so let's do that, because this we haven't done before. The others we have, it's just extra practice. Find the equations of the three altitudes. So we know, I better plot these first. So we've got here we've got here A is 3, 5. And B is 2, 3, and C is 5, 2. Okay, so find the equations of the three altitudes. So we said that an altitude is from one vertex to the opposite side perpendicular. So if it goes from one vertex to the opposite side, then we know that the point, because remember, to find the equation of a line, an altitude is a line, we need a slope and we need a point. So if we're given the point, here's the point that we're given for this one. So let's find the altitude of it, altitude from A. So from vertex A across to point BC, that altitude is going to be, we need a point, so the point is 3, 5, and we need the slope. But wait a minute, we don't have the slope. Okay, so how can we find the slope? If this line is perpendicular to this line, if we know the slope of this line, then we can do the negative reciprocal and know the slope of this line. Can we find the slope of this line? Sure we can, because we have 2 points, so we can find the slope. So let's do that. Slope equals y2 minus y1 over x2 minus x1, which is for BC, we've got 2 minus 3 over 5 minus 2, which is negative 1 over 3. So that's the slope of BC. So the slope, so the perpendicular slope of negative 1/3 will be 3 positive. So the slope that we're using for our altitude line is that. The point we're using for our altitude line is that. So now what we need to do is we need to find the equation of the altitude, because it said find the equation of the three altitudes. So we've got y equals mx plus b. Y is 5, m is 3, x is 3 plus b. 5 equals 9 plus b. 5 minus 9 equals b. So that's negative 4. b equals negative 4. So now we've got y equals m x plus b. Done. So now we have to find the equation of the other two altitudes. So let's do that. Altitude from B. So altitude from B is going to be, first we're going to have to write down what B is. And now I'm going to find the slope. From B, B goes to line AC, line segment AC. So I've got to do the slope from, I should have written here, the slope of, this was BC, and this is the slope AC. So y2 minus y1 over x2 minus x1, and A and C are up here. So I've got, just move this up a bit. So A, C are here. So I've got 2 minus 5 over 5 minus 3, which is negative 3 over 2. So the slope of perpendicular to that is positive 2 over 3. So now I've got point and slope, so I'll do y equals mx plus b. And then I've got y is 3, m is 2/3, x is 2 plus b. So 3 equals 4 over 3 plus b. 3 minus 4 over 3 equals b. Find a common denominator is 3, so times the top and bottom by 3. And we will have 9 over 3 minus 4 over 3 equals b, which is 5 over 3 is b. So y equals slope is 2 over 3x, and y-intercept is 5 over 3. So there is my equation of my altitude from B. So now I'm going to do the equation of my altitude from C. Actually, I'm not going to do it. I'm going to let you do it without me showing you. So you go ahead and do that. But before you do, let's just take a look at what the next thing is. It says, verify the intersection point of any of the two altitudes. So here's this thing. We have two of these, right? So we're going to need to find the point of intersection. Remember last chapter we learned how to solve a system where we learned how to solve the intersection point of two lines? So that's what we're going to do. We have here y equals 3x minus 4. We have here y equals 2/3 x plus 5/3. And we're going to need to solve that system. So let's do it. And you can do this on your own after, because I know you can do that now with these two examples. So here I'm going to sub 2 into 1. So if y equals this, then I can say 2 over 3x plus 5 over 3 equals 3x minus 4, right? Because y I'm replacing with all of this. So y is this, and then there's that. So I did 2 goes into 1. So now I'm going to solve for x. First thing I'm going to do is get rid of these fractions. So I'm going to multiply everything by 3, 3, 3, and 3. I'm going to get the x's together, 2x minus 9x. Get the other numbers together. That's minus 7x. That's minus 17x. Minus 17. And then I've got a yucky non-rounded off number, but nevertheless positive 17 over 7. Then I'm going to take that and I'm going to sub it into either of these equations, doesn't matter, so I'll sub it into 1. And I've got y equals 3/17 over 7 minus 4. So y equals, what's 3 times 17? Well, let's see. Let's say you don't have a calculator. You can always do this, right? 17 times 3, 1 carry the 2, 5. 51 over 7 minus 4. So I need to find a common denominator. So I've got y equals 51 over 7 minus 48. 7 times 4 is, 28. So now I've got 51 minus 28 over 7. So that is, let's see here, we've got 33, right? 33. So verify that this point, the orthocenter, is on the altitude not used in point B. So what does that mean? That means that now that I found this point, xy, I need to find this altitude. And then I need to plug in x and y and make sure left side equals right side to confirm that this is a point, not only on this line and this line, but also on this line, because remember I said, when I went through the terminology, that where the three altitudes meet is called the orthocenter. So that's what you need